Before we can start any spraying operation, we must be fully conversant with the spray systems that we're going to use. First of all, the chemical is pumped into the tank through the inlet. Once in the tank, it's pumped out via the outlet hose here and through a wind-driven pump with a brake on it, so as when we do run out of chemical we can stop the pump from turning. It's pumped out and through a three-way spray valve. There are two types of spray valves, this one being an electrically operated one, and we also have mechanical operated. When the spray valve is shut off, the chemical is pumped back through a hose into the tank and is just recirculated. When the spray valve is on, it is the recirculation hose is closed off and it's pumped out through the outlet to the boom. Now we'll go around and have a look at the outlet side of the spray valve. On this side of the spray valve, first thing we'll look at is we have a little bleed off valve in the back, and what it's for is when we turn the spray valve off, it bleeds the pressure straight out of the booms. With the spray valve on, the chemical continues out and pressurises the booms. We have two systems of dispersing the chemical from the booms. The first system we'll look at is what we call a T-jet. The chemical comes out of the boom into the outer body of the jet, flows up, over and down through the centre and out the bottom. Now what we have is a little rubber grommet and a spring that acts as a valve on top of the jet. And the valve opens when there's 12 psi or more pressure applied to it. The chemical then runs down through a filter and into what we call a hollow cone nozzle. The first part of the nozzle is what we call a swirl jet. This gives it a swirling motion. It has a number on the centre of it, and the larger the number, the larger the jet size and the more fluid that's allowed through. Then we have the hollow cone itself. It's just a cone with a hole in the centre, and the larger the number once again, the larger the hole size. They are put together and clamped to the boom like so, and to get different dispersal rates we refer to a graph which we'll be seeing shortly. The other system that we can use on this T-jet is what we call a flat fan jet, and it works exactly the same. It has a set of numbers along the front to indicate the size, and we just go to a graph to find out the calibration rate for that. And the other system we have is a rotary atomizer. The atomizer body here attaches to the boom via this clamp, and the base of it, or the back of it, spins in the airflow. It actually starts with what we call the VRU, which is screwed into the boom. The fluid comes through and out the bottom. The calibration for the rotary atomizer is through a set of numbers, and we relate them to a graph in a book that is supplied with the unit. And then the chemical runs into the hose and into the body of the atomizer here on exactly the same principle as with a T-jet, in that we have a rubber seal The fluid then breaks the seal, runs down through the centre of the system to a jet in the back here, and then it is sprayed out through this cone. The smaller or larger the drop that we want, we can change simply by changing the angle of these blades and spinning all this hub faster or slower. The angle of the blades to the RPM and the airspeed we can get out of the book that is supplied with these Micronair units. Before we do any spraying, we must be able to calibrate the aeroplane and know the required amount of chemical that needs to be put on. To calibrate the aeroplane, we have a formula, and we'll run through that formula now. We have the speed the aircraft is going across the crop in knots, by our swath width in metres. If we divide that by 444, it will give us the hectares per minute that the aircraft is covering. In the case of our aeroplane, what we've got is the aircraft travelling at 105 knots with a 20 metre swath width divided by 444. We find that we're actually covering 4.7 hectares per minute. The required application rate for the type of chemical that we're putting on, found off the side of the drum, is 20 litres per hectare of total mixture. And to get that, we have 4.7 hectares per minute that we're covering. At 20 litres per hectare, we will need to be putting out of our aircraft 94 litres per minute. We have two types of spray systems, the boom and nozzle and the Micronair. Initially we'll look at the way we calibrate a boom and nozzle. In this case we have 24 nozzles on the booms and 3 different setups in that D4, D8 and D10 orifice plates and 45 for all 3 the swirl plates. Here we have pressures, and for each pressure we have a given flow rate for those 24 nozzles. In this case we can see that D1045s at 40 psi will give us 94.1 litres per minute. So this would be the setup that we would require to calibrate our aircraft. On the other hand, if we come down to the Micronairs, we just have setting numbers, pressure and the flow rate in litres, and this is of one Micronair only. In the case of this aircraft we would fit it up with 8 Micronairs. We would find that setting number 12 at 40 psi would give us 11.75 litres per minute flow, multiplied by 8 gives us 94 litres. Now what we do once we've decided what setting to use or what nozzles to use, we'd put a given amount of liquid in the hopper, normally just water. In this case we'll use 94 litres. We'll double that, so as in 2 minutes we'll put out 188 litres. We'll then go and fly the aeroplane for 2 minutes, and we should find that when we arrive back at the airport that we've used all the water. Now normally what we do instead of just going up in the air and spraying it is run up and down the field. This is to contain any drift and so as we don't have people complaining about aircraft just spraying in the air. After checking the calibration of the aircraft and briefing the markers, we'll now have a quick look at the map of the area just so as we can familiarise ourselves with it. It's 1.5 kilometres to the south of the airstrip, and it's 20.5 hectares to be sprayed. It has a power line in it, trees on the eastern end. The main thing to worry about is a house on the western end of it. We'll look at this in more detail when we get out in the paddock. Now the next thing we need to do is work out the load that we are going to carry out to the paddock. And from the PA chart we've worked out that we can cart 279 kilograms, which is in actual fact 279 litres. We have a 20.5 hectare paddock, at 20 litres per hectare, we will need 410 litres of total mix. And as we can see, we can only cart 279 litres. Therefore, we'll have to do it in 2 loads of 205 litre loads. The chemical to be applied will be 750 ml per hectare, and our 2 loads will be 2 10-hectare loads, which means we'll need to put 7.5 litres of chemical in per load. While we're actually out spraying, we can check that our calibrations are correct simply by using the same formula that we used in the top dressing. The length of our swath is 603 metres. Multiplied by the width of our swath, which is 20 metres over 10, will give us 1.2 hectares per run. Now at 20 litres per hectare, we will use 24.1 litres on every run. This means that each load we will do 8.5 runs a load, and at the end of each run we can actually check in the hopper that we've used 24.1 litres on the run.
When spraying, an aircraft deposits material in 2 ways. In still air, materials are deposited through sedimentation. The larger droplets drop straight to the ground, the smaller droplets drift to the ground. In windy conditions, 5 to 8 knots plus, the larger droplets are still deposited by sedimentation, but the smaller droplets are deposited by the turbulent airflow over the crop or ground. There will always be some drift. However, once appreciated, drift can be used as an aid to spraying.
If in a light wind condition spraying, we can use this turbulent airflow in an aid to disposition of our spray droplets by flying on the tops of the trees and allowing the wind currents to actually carry the spray drift down into the position that we would normally not be able to get if we flew alongside the trees.
Here we're seeing that theory put into practice. Next, when to turn on and when to turn off on a spray run.
Okay, spray run, slight headwind, so we just wait to turn on a little bit after we go over the fence, and we'll turn off just after we go over the fence to allow it to drift back. This time we'll have it a slight tailwind. We'll turn on a little early and turn off a little early. And off a little early descent.
Jettisons. The reason for a jettison can be an incorrectly calculated load, encountering downdrafts, or an unforeseen stall. If a pilot needs to jettison, make the decision early and act immediately. The aircraft will pitch up, so be prepared to retrim. Always be mindful of where jettison chemicals are likely to fall. Some chemicals are very expensive, and it may not be necessary to jettison the lot, but when in doubt, jettison the lot. This is the standard procedure that should be followed when preparing to undertake spraying operations.
Let's see what all we got here. We've got a 20 hectare job to do.
Remember, no matter how good the pre-flight calculations are, they're useless if not clearly conveyed to the loader.
DDT.
In this case, the pilot informs the loader that he has a 20 hectare paddock to spray.
20 litres.
He will need 2 loads to cover the paddock, and 7.5 litres of chemical will be needed per load, in a total mix of 205 litres.
I'll give you a yell when I've got me 400 litres in there.
Okay.
We're now taxiing out on a complete spraying of a paddock. Taxiing reasonably slow. We now have a full load in the aeroplane. We don't want to taxi too fast. Our pre-takeoff checks are completed. At this stage we'd take the fan brake off and allow the pump to start spinning so as the chemical doesn't settle and keeps mixing with the water. Don't make any abrupt movements taxiing, any very sharp turns. It'll need a lot of power. Otherwise we put too much stress on the engine mounts and gyroscopic force on the propeller and so forth. Seeing as we have a full load in, we'll go right to the end of the strip and use as much strip as possible. Turning around, lining up into wind, checking all clear, and apply power for a takeoff. Once airborne, climb straight away to 100 feet and start your turn into the direction of the field. some way to a safe height. Normally 300 feet is high enough for tracking to the job. Using the map that the farmer has given you, I'll give you some idea where the paddock is. In this case, it's 1 mile due south of the airstrip, which we saw when we were doing the marker briefing. We've sent the markers out into the paddock. We'll fly around the paddock and do our checks. And when we're satisfied, we'll start spraying. Now, as we're approaching the paddock, we just check a dam or some form of wind indicator. We found out that there is a light breeze blowing, and it's blowing from the northeast, which we'd already told the markers to start on the southern side. The markers are there, and the paddock fits the identification on our map. The sun today will not be a problem as we have a cloud cover, and the sun doesn't look as though it's going to come out from the clouds today at all. The hazards we seem to have in this paddock are 2 trees on the eastern end and our power line running right through the centre, and a power line running up on the northern road boundary. First of all, we check that we know where every power line is, and what we'll do now is fly over the top of the power line running through the paddock, checking that there's no spur lines coming off it in the paddock. Crossbar right in front of us on the first pole. That's outside the paddock. It's not going to worry us. One running up the roadway, and a power line runs straight through to the house in front. Having convinced ourselves that there are no wires running off, we'll let down between the poles and check it for height. Just checking out to our left-hand side that it is in fact high enough. There's plenty of height there. Continuing on with our check. We don't have any susceptible crops to the south or southwest. It's all pasture land. Terrain is flat, and all the terrain around is flat, so we won't have a problem turning or tracking across the paddock. Access to markers is quite okay. We've got the markers in the paddock. The nuisance is all the houses around us. There's houses to the north, houses to the west. The direction in relation to all that would be east-west. Will keep us away from the majority of houses, and also it makes the longest run. And the emergency landing areas either side of the paddock are very flat paddocks, no power lines in them. So we were actually ready to start the run. Take a wide turn and line up on the 2 markers. I'll start the move any minute. As we come in, the markers are moving over the fence and we start to spray. Just before the fence, turn the spray off to allow for any drift. As you remember, we'll have a slight downwind component from the northeasterly, so it will, we can't afford to turn off a fraction early and the spray will drift onto the downwind headland. As we go over the fence, we can delay our switch on just a fraction, seeing as we got that drift. And on the upwind fence here, we'll delay the switching off of the spray to allow for the drift as well. As for all our procedure turns, we're using flap in the turn to tighten up that radius of turn and to decrease our stall speed with a full load on board. Markers are coming back into view now. Rolling out on the markers, the marker will start to move, removing the flap and tracking straight into the paddock. As we come to the dam, we just turn off over the dam and back on again, finish off, then off over the fence. As you can see, at the end of our run we have a house, and we must endeavour to keep more than 100 metres from the houses unless we have specific permission. In this case now, at this end, our turns will be such that we track in and then turn back in as we go round the house. Markers are moving. We turn on and off very quickly here as we go over the dam, then back on to finish the run down the paddock. As you can see, at the moment our angle is starting to get more acute down this end as we have to negotiate the house before negotiating back onto our markers. The power line isn't presenting a problem here. At this stage, a tree is going to start to present a slight problem. Seeing as it's a single tree, we are far better off to just go one side or the other of it. And hopefully the marker will have done the same thing. can see there the marker has moved slightly away from the tree. We will come in just do a gentle skid round the tree, level off under the power line and track directly up to our next marker. We're now getting closer to the house and it is becoming more of a problem. As we're getting closer to the northern boundary here, we must start to think of what we're going to do with the last run in relation to laying our swath up against the boundary. As we can see, there is a power line there. It's obvious that we're not going to be able to stop down on the ground. Come past the tree here, kick in, line up on our marker and straight through. What we will have to do is fly a power line height, one swath out from the paddock and allow the spray to drift back in onto that last run. As we can see, that was the last run on the markers. We will endeavour to come in over the power line. Flying spray on and allowing the chemical to drift back into the paddock. We'll pull up at this stage, quickly reassess the obstacles in the paddock, the two trees up on the eastern boundary and the power line running crosswise, and especially the power line on the road. We're going to change our direction of spray now for the clean-up runs. And the first one we'll do is on the eastern boundary. The power line stops half-fly along the paddock on the roadside and it won't create a problem for this clean-up run. Because we have a easterly component, we'll do the eastern end first, because any spray drift would have drifted away from the fence, whereas the western end it would have drifted onto it. After assessing for obstacles, we come around and we'll stop approximately one swath width out from the fence to allow the drift back in over the fence and past the trees. If we have any spray left, we do a run down on the western boundary. The problem with this boundary is that we've got houses the power line to go over. And we'll stop a swath width then. We have a few trees just to mark the power line. Make it a reasonably steep descent to keep away from the houses. Spray on. And off. The job being completed, we should now be out of chemical. We would put the fan brake on to stop the pump over revving and return to base by the most direct route at approximately 500 feet. The majority of wire strikes, when the pilot's finished the paddock and does his clean-up runs, he tends to forget about the wires. So it's always very important to do a reassessment of all your obstacles before doing the clean-up runs at the end of the paddock.
A range of application heights are used, depending upon wind conditions and the chemical that's to be applied. At low level, there's less risk of hitting power lines or other overhanging objects. However, markers are difficult to see. Higher up, it's harder to maintain height and to control drift.